as well the experiences she has in this industry. So moving forward, Ms. Bola Atedola is a master's graduate of business intelligence and big data from the University of Greenwich, and a data analyst, as well as a science professional with over 9 years of working experience in application support. She can also be considered a data scientist, a data analyst, and she has worked in the field of data science, analytics, visualization, machine learning, and business process improvement. So today, Ms. Bola Atedola, or Atetola, sorry for that, I had a little bit, yeah, so she would be explaining to us today, and as well exposing to us some of the skills to possess, and as well the skills to process, in order to embark on that journey of becoming a data science. So without further ado, I think we've wasted a little bit of time. We would be going straight into the session. So over to you, Ms. Bola Atedola. I would employ all of us to sit tight while we enjoy the session.
Thank you.
Sorry, good evening. Apologies for coming a bit later at the time. I had some technical issues to deal with. Okay, so without wasting much of our time, let's go straight into the business of the day and becoming a data scientist. That is what we, that's the business of the day. Now, I'm sharing my screen. I want to just confirm if you guys can see my screen.
Yes, we can see your screen.
Yeah, we can see your screen.
You can see my screen. Okay, beautiful.
Yes.
So let's start. Like I explained earlier, it is becoming, the topic is becoming a data scientist. Can I have like an idea of the audience? Do we have people who are just starting, people who are, anybody already in the business, or someone who is already on the expert level? Do we have a mix in the audience, or if we are just mainly maybe beginners or intermediate people? So I just want to have an idea of my audience.
Okay. Yeah, I'll consider myself intermediate data scientist as well. I've not really had so much experience in the field, but I'm starting out as well.
Okay, let's start then. Thank you.
Yeah, you have intermediate here.
Nice. Okay. So the content. Hello.
Hello, I'm hearing you. I'm hearing you.
Good. So we are first of all going to start with the introductions, reasons why we give ourselves not becoming a data scientist. Then there are three things that people usually mix up, and that is data science, data analysis, and data engineering. We are going to talk about the three of them. They are not the same. They are similar, but they're not the same thing. And then we'll difference between each of them. We'll give examples in their roles. And then when we have a better understanding of what the differences are, then we'll go to the focus of the day, which is the data scientist. We'll talk about who is a data scientist and what they do. We'll also talk about the skills. So you have your soft skills, you have your technical skills, then you have the beginner, the languages and all that when we get there. Then we have things that could impede our growth. And then we have tips for getting jobs and roles, and then questions. So that's the progression in which we're going to go today. So let's start from the beginning. Let's start now. So we have, when you heard the word data science, data scientist, sometimes it can be a bit overwhelming or scary, but really it's just more or less like a title or a job role. There's really not this. So you hear people say, oh, I studied Yoruba linguistics at the university. I cannot be a data scientist. Or I studied what weird course, Chinese language. I studied botany, I studied something, so therefore I cannot switch to data science. Those are kind of the myths that you hear. Or you hear, I'm too old. I know of somebody who is in his 40s. He's about 45 and he's just learning data science now. And he's made lovely progression and he just started about a year ago. Or the other way is I'm too young, I'm a lady, I'm a girl, or data science is a man's world, though I cannot do it. Or the only guys can, it's only guys, like, I'm a lady, how can I be a data scientist? Or you heard data science is for only nerds, it's for people who like to carry books. And if you are a data scientist, you cannot have a life, you cannot, no, all those things are not their myths. And you hear some of data scientists is an expensive venture. You do this course, you will go to school, you will down. All you need is just a laptop and your zeal and some internet, and you're good to go. It's really not an expensive venture. It's at least it's not as expensive as medicine, and you don't have to use like 8 years in school before you become a data scientist, like unlike medicine and other courses. And then you hear things like, "Oh, I lack the practical skills. I don't know any programming language." Nobody, if you don't learn, how will you know? So even if yes, you do not have the practical skills, it's not, the data science is also something that is easy to start as long as you start from the basics. And that basics and the foundation is what we're here to build and also see how we can build on that and grow. So having dealt with a few of the things that we give our reasons why sometimes we tell ourselves that, okay, this data science thing it looks like something that'll be difficult. Let me move over to something else. No, let's now go deep into it and let's now see what this whole data science thing is all about. So initially, and when I was going through the content rather, I said we're going to talk about data analysis, we're going to talk about data engineering, and then we're going to talk about data science. So what is data analysis basically? Data analysis is the process of extraction of information from a given pool of data, and that is called data analytics. You have your Excel, you have your maybe a database, and pulling that information out of it basically that's what data analytics is all about. And a person who engages in this form is called a data analyst. Please excuse me, please. Oh, I'm sorry about that. I had to, my charger, my laptop screen was. Okay, so as we were saying, we're talking about what is data analysis. And instead, a data analyst is someone who engages in this form of data analyst. I hope you can all see my screen.
Yes, we can see your screen.
Yes,
Okay.
we can.
So a data analyst extracts information through several methodologies like data cleaning and conversion and data modeling. And there are different fields where you can use this data analytics: medicine, technology, finance, entertainment, etc. With data analysis, organizations are able to perform, analyze trends in the market, and also see the overview of their performances, and allows them to make careful data-driven decisions. The data analyst basically helps them to, you've seen, I don't know if you've come across some reports that have different types of charts and stuff like that. So the data analytics will take your raw data and bring out something in the form of a some bar charts, some pie charts, and all that stuff, and then make it into some beautiful dashboard, and then the management will be able to understand it. So you have the descriptive or summary statistics, and then you have those are some of the techniques that is being used in data analysis. And then a data analyst is some of the tools they use, the SQL and Excel. Now let's go over to data science. Data science combines multiple fields: statistics, scientific methods, AI, data analysis, to extract value from data. So we've talked about data analyst. Basically, they don't do data analysis, doesn't include things like AI, doesn't include using statistics or scientific methods. It's a basic, very basic, like first level. Data analysis is actually included in data science. So as a data scientist, you are expected to know how to perform some data analysis. But meanwhile, if you're just a data analyst, it's not expected that you will know much about data science. So there is that's the thin line between data analyst, being a data analyst, and being a data scientist. So you can be a data scientist and a data analyst. But if you're strictly a data analyst, someone who is strictly a data analyst may or may not be a data scientist. So that's why sometimes the role is being interchanged between each other. Data science can be thought of an notion that includes all data operations like extraction, data processing. These are things that you might also do in data analysis, but then it includes something like data prediction to gain necessary insights. This is something that you may not necessarily find in data analysis. Companies extract data to analyze and gain insights about various trends and practices. And in order to do this, you have different statistical tools and programming languages. In this case, it's machine learning and it's algorithms that are being used. And these algorithms are responsible for predicting future events. At the core of data analysis is all about getting data for analysis and producing meaningful and useful insights. The data can then be further applied to provide value for machine learning, data stream analysis, business intelligence, or any other type of analytics that you may find. Now, the last one, which is data engineering. Data engineering is like the foundation. I think a few weeks back, there was one of these deep dive series that they talked about DevOps. And the speaker also mentioned something about cloud engineering and all that, differences between cloud engineering and DevOps itself and stuff. A data engineer kind of uses a platform like cloud, for example, to create pipelines in which the data scientists and the data analysts will be able to work. Now, while data scientists are just concerned with the exploration of the data and finding insights, building machine algorithms, the data engineering cares about making those algorithms work on a production infrastructure. So they are the infra guys. They are the ones who ensure that you have the platform in which you can work on. So data engineering, that's the difference. It's basically an engineering role that requires the creating and managing the technical infrastructure of the data platform, where you can then carry out all your data analysis, science tasks, or your data analyst tasks and all that. A data engineer manages the data pipelines, which is basically the flow of data from one system or platform to the other. And then your skills you will find here, you have your Java or Hadoop, big data, basically, big data skills, and you must have some data modeling algorithms, ETL techniques, and then data warehousing. For example, Amazon Redshift, for example, that's an example of data and warehousing skill that you must have. So we said we need to see the difference between each of the roles. A data analyst does pre-processing of the data and gathering the data. A data engineer will develop, test, and maintain their architectures. Or a data scientist is responsible for developing operational models. People that are closer to management, you will find that data scientists are closer to management than data analysts. Data scientists, when the management wants to get information that, oh, we want to know what the trend, we want to know what the future is going to look like. A data analyst will just take the data and can tell you what happened in the past. While a data scientist will take that same data and will be able to predict in the future that, okay, this is what has been happening. But if we do this, if we use certain algorithms, we can then develop certain trends that you'll be able to see, okay, that this is what is going to happen in the future. So they're responsible for developing operational models that are being used to find all these insights that we're talking about. Now, emphasis for data analysts, the emphasis is on representation of data, reporting, and visualization. Basically, that's what they do mostly. The data engineer will understand the programming and its complexity. While like I said earlier, the data scientists will carry out data analytics and optimizations using machine learning and deep learning. The data analyst also is responsible for statistical analysis and data interpretation. The data engineer will deploy machine learning and also the statistical models, while the data scientist is involved in the strategic planning for data analytics. Now, who is a data scientist? We've talked about who is a data engineer. We've talked about who is a data analyst. We've seen the differences in the roles. So we've talked of the confusion about what makes a role for data analysts and what makes a role for data scientists. As if we've been able to draw that line. We've made to make a clear line with the clear distinction. Now let's talk about who is a data scientist. A data scientist uses data to understand and explain the phenomena around them and help organizations to make better decisions. The typical salary for a data analyst is about $59,000 a year. But a data engineer can earn up to $90,000. But a data scientist would earn about $91,000 per year. But this is, you must be someone that is already in the game, know what you are doing, and you already have some experience. So, but it's just basically to let you see that this is the progression. So it's not just about being a data analyst. You can grow in the field, become a data engineer, and also to become a data scientist. Now, still on the topic of who is data science. They find patterns and trends in data sets to uncover insights. They create algorithms and data models to forecast outcomes. Like I mentioned earlier, a data analyst talks about what happened in the past. A data scientist will use algorithms to create what is going to happen in the future. So you're more like a prophet of data. You are prophesying, or you are predicting that, oh, if in the next 1 year, in the next 6 months, this is what is going to happen. So like that's like a data scientist, what he or she does. They use machine learning techniques to improve the quality of the data or the product offerings. And then they deploy tools like Python, R, SAS, SQL in data analysis. Like I explained earlier, a data scientist has the skills of a data analyst. And then they stay on top of innovations in the data field, science field. To be a data scientist, there are certain skills that you must have. So we talked about we're going to talk about the technical skills and the non-technical. I'm starting with the non-technical, which are the soft skills. Usually these soft skills are things you um, sorry, in most jobs, but coming now to the data science role, you need critical thinking. You must be able to think out of the box. You must be able to think quickly. You must be able to look at your data, ask questions about what the data is. So you need, those are kind of things you need to develop within yourself. So it's not just about having the technical skills now. You can have the technical skills, but these non-technical skills you also need to have. You need to be able to communicate effectively, whether it's via email, because you'll be interfacing with a lot of teams. You'll be interfacing with management. So you should need to be able to communicate your what you've done correctly. You need to be able to, whether it's oral or verbal, or whether it's written, making your presentation, you need to be able to communicate effectively. You need to have problem-solving skills, proactive problem-solving skills, because data science is a field whereby you are talking about predictive analysis. You need to be able to be proactive when it comes to problem solving. You need to be able to see the situation, the task. You need to be able to know what actions you're going to carry out, and you should be able to know the kind of results that those actions that you're going to carry out is going to give. You need to be able to carry out research. So you have you have a problem. You need to be able to know where to go to. You're going to do a lot of reading, a lot of, if I must say, Googling. Google is your best friend. You need to know how to do some research. Analytics is like, is a must have. Those are the kind of things you must have. And then intellectual curiosity, you must be able to, some great data intuition. You have a data before you, and you're able to say, oh, within this data, you should be able to clean the data. You should tell a story out of that data, because that is what is expected that you should be able to do. Because the people that you are presenting this data to, they don't have time for long story. You should be able to take that data and you should be able to know, oh, this is what this data is about, and be able to talk about it. You should have some business sense. So you have, like I said, you'll be interfacing with management in most cases. So you should be able to understand what the business itself is all about. So when you understand, for example, maybe you're working with a financial institution, you should be able to understand how it works. Or you're working with a telecoms company, you should be able to understand the kind of subscribers that they have, the kind of products that are in that company. You should be able to understand the prices and the different things that within that company. You should have that business sense. Then the last thing is, you should be able to take ownership of your data. You have cases whereby people will say, oh, it's not I'm not the one doing it. It's not my business. And then they start passing the ball here and there. If you are going to do that, you're not going to achieve anything. You need to be able to take ownership of that data from the beginning to the end. To be able to take it, pass it through different pipelines, from the data cleaning to the data exploration phase, to when you're going to create your algorithms and you're going to get your answers out of it. So like I said, you need to be able to, these are some of the skills. These are some of the critical skills that you should have. There are others, but these are some of the main skills that every data scientist must have in order to be successful in the career. So now that we've talked about the non-technical skills that you should have, now let's talk about the technical skills. So you should be able to prepare your data for effective analysis. What do I mean by that? You are given a data, for example, in an Excel sheet or in a text document for something. They'll just give you a text. Somebody extracted one text file from the database, or they got some Excel sheet, some CSV file that they were filling from God knows where. And they give it to you. The columns are in the full number columns. You will see spaces, you will see comma, you will see dash, you will see incorrect numbers, for example. Or in the names, you will see some names that start with capital letters, some names that start with small letters, some names that are all caps. You should be able to take that data, you should be able to clean it, and then prepare that data to be able to now say, oh, this is what you can get out of it, because it's not all data that's clean. It's not, some of them, you have something called structured data and unstructured data. Your structured data is already in a table form. You have where it's already good. But then you have your unstructured data where it's all scattered. It's in different formats, and then you're asked to then put it together and work something out of it. So that's one skill you should have in terms of the technical skills. You should be able to prepare your data so that you can then take that data and get some valuable insights out of it. The next thing you should be able to do is to make use of data visualization tools. Like we explained earlier, the data analyst basically makes use of this same data visualization tool. But you, as a data scientist, you also carry out the job of a data analyst, and you take it a step further. So you should be able to make use of these data visualization tools. The basic, at the very least, Excel. You should be able to take an Excel, draw some pivot charts after we carry out some nice visualizations with it. Other visualization tools like Power BI or Tableau or QuickSense, or different ones in the market right now. Then you should be able to write efficient and maintainable code, in the sense that if somebody else comes and picks your code, they can make some sense out of it. If someone gets your code, it is error-free. You can run that code and it will give you the results that you need. There's a way you can write a code and you can write it in 100 lines, but it's saying, and then to carry out a particular task. But then maybe you can also write that same code again to carry out that same task, but you will need more than 20 lines. Now that is being effective. So you should be able to write effective and maintainable code. You should be able to apply math and statistics appropriately, because statistics is something that you would do as a data scientist. And you should be able to make use of machine learning and AI also in whatever thing you're doing. Now, we've talked about the technical skills, we've talked about the non-technical skills. Now let's talk about what you need to learn in terms of the languages and the skills that you need to apply, that you need to get. So I've divided them into beginner, experts, and intermediate, and then the expert skills. At different levels, there are certain things that's expected that you must already know. So starting from the beginner, what should I learn? You are a newbie to Python and you're starting from somewhere. What are the things that you need to learn? You need to learn the Python fundamentals. You need to be able to download and install Python or whatever machine you're using. That's the first thing, and it's a successful installation of the Python on your system. Now, when you've installed Python, you need to be able to work with it. Now, there are different platforms in which you can work with Python. You have IDEs. IDEs are basically integrated development environments. You have Ideal. Ideal, when you've installed Python on your laptop, Ideal is the IDE for Python. It's basically integrated development learning environment. That's what Ideal means. It comes with a Python package. already. You have another ID called Spider. There are different types of IDs. These are just two different examples out of the different ones that you have. Then you have your editors. Even your notepad is an editor. You can write your Python code in your notepad. But then you have much more advanced ones that help you highlight your code in a better way. You have things like PyCharm. You have Eclipse. Then you have the web-based interactive computing platforms. Most of us already know those ones, the Jupyter Notebook. You have your Google Colab, where to write your Python codes and they help you to run your Python codes to be able to get the information out of it. So now that you've been able to download Python, you've been able to install it on your laptop. Then you have your ID, or you have the web-based ones in case you don't want to install it on your laptop, you want to run it from the web. You can then run the Jupyter Notebook from the laptop, install Jupyter on the system, and then also Google Colab, whether that's what you want to use. Then some of the things that you need to learn under Python, you need to learn about variables, strings, and arrays. You need to learn about loops, conditional loops, the if, the else, and all that. You need to learn about Python functions. You need to learn about lists, tuples, and dictionaries. Under dictionaries, you have something called the nested dictionary. So all these are not, you've not even started the libraries and all that. You are learning the fundamentals of Python. Python goes beyond, I know pandas, I know NumPy, I know TensorFlow, or some things like that. You need to know the Python, you need to know the fundamentals, because when you go for interviews, these are some of the very simple, they start from simple places like this, and most people just fall out, because if you cannot do 2 plus 2 in Python, then, that's the basic. So these are the places where you need to start from things like this. You need to know your numbers and your math. You need to know how to know the integers and the floating point numbers, arithmetic operators, and expressions. Those are some basic things. And then we now move to installing packages with pip. Pip install. That's when it now comes to when you're installing your maybe something like scikit-learn, or you want to install import your packages, something like TensorFlow and all that. So basically, these are some of the fundamentals that you should know when you're starting to learn Python. That's the first language. The other thing you now need to learn is SQL. SQL basically means the structured query language. It's the programming language for databases. So you have most databases would use SQL. Your Oracle database, whether it is the Postgres, whether it's MySQL, or even MS Server. MS Server has its own SQL language. It's called TSQL. So as a data analyst, as a data scientist, you should learn SQL also, because you'll be required to write SQL queries that you use to extract information from this database. And then the data you've extracted, you would be required to use it to then carry out some predictive analysis. And you'll be able to tell exactly what's going on. Maybe, for example, you're working for, let's say, a telecoms operator, for example. In Nigeria, let me say you're working for Nine Mobile, or Airtel, or MTN, or something. And they say, oh, we want to know all our subscribers that are using our data plans. You, as a data scientist, you should be able to write an SQL query that would extract the subscribers that are using the data plans, for example, for this telecoms operator, and then carry out, and then you bring after extracting it, you then be able to work with it using Python to then give some insights that, okay, the management will know, maybe you're using charts, do some data visualization. They'll be able to know that, okay, the 5,000 of our subscribers bought 2 GB plan, 10,000 bought another 6 GB data plan. And if we carry out, we found out that there are more people in Lokoja than more people in Kafanchan, or something like that. You should be able to tell a story from that data and present it to the management. So that's about SQL. Another language that you need to learn is R. When you see job descriptions, and maybe before the end of the this session, I will show you some job descriptions for a data scientist, and you will see that most of them, they're always asking, do you know Python? Do you know R? Do you know SQL? Those three are the basics that you must know before you can, when you're starting your data science journey. You should be able to know R, you should know R, you should know your Python, and you should know SQL. So under R, you have your introduction to R, the vectors and data frames, missing values, package, deploy. You have there's something called tidyverse also under R. Then you should be able to know how to do some data manipulations. You should be able to import, export, and transform data using R. Then you also know your statistics also, just like with Python, you should be able to know your statistics also with data science, with R, sorry. And then you should be able to do some visualizations. There's something called ggplot too. It's a library you will find inside R that is being used for graphics or visualization. Then you should be able to carry out data processing in something that is called a carrot environment. The carrot environment is where you do your data processing for that you'll be able to analyze it in a way that it will be suitable for machine learning. So that's about R. So if you know these three, you'll be able to do a junior data scientist role. If you know those three successfully, and it will take you about 2 to 3 months of studying. As in you're studying, you're doing projects on it, it should take about 2 to 3 months for you to master those three. 2 months, if you're very serious about it, you should be able to do that in 2 months. But 2 to 3 months basically, and your beginner level will be covered. Now let's go to the intermediate. So you already know your Python fundamentals. You already know your your R, you know your SQL. Like I explained earlier, the data scientist, as a data scientist, you'll be required to carry out some data visualization. And then some tools that you're also required to know is Tableau and Power BI. Then you must be able to carry out some statistics. Under statistics, you have a general statistics. You'll be able to calculate your mean, your median, the minimum value, the maximum value, your standard deviation, the variance, the range, the quantile levels between the lower one and the upper one, as in basic statistics. Because those are your as a mean or average, as the case may be. Then you should be able to do some probability distributions, some dimension reductions, oversampling, undersampling. Yeah, sometimes they might give you your data, and what I mean by oversampling or undersampling is maybe, for example, you have a data and part of it is not balanced. Basically, you have one feature that is more than the other. Maybe, for example, your data is about fraud, and they're trying to tell which transactions are fraudulent or which transactions are not fraudulent. So you have your data, and maybe the ones that are fraudulent are more. Maybe, for example, 900 to 100. Now, in that case, you have one that is being oversampled and the other side is being undersampled. You should be able to carry out with statistics. You should be able to balance it up so that you can be able to carry out some predictive analysis on that data. Then you have things like your EDAs. EDA basically means your exploratory data analysis. So under EDA, you have pandas. You have those are the things that the very popular pandas, NumPy, Matlob plot library for a way to draw your graphs, your pie charts, your bar charts, your scatter plots, your correlations. There's another one called Seaborn that I was going to include in this list also, that you can use to carry out your exploratory data analysis. So here basically is where you carry out your data preparation, your data cleaning. You can use pandas, and NumPy to clean your data, and then you carry out some graphs with the Matplot library. Now, under these intermediate skills, you then move to the machine learning techniques. You have the basic thing ones. There are others more than this, but the basic three that you should learn: supervised learning, unsupervised learning, and semi-supervised learning. Supervised learning is basically you have a data that is already labeled. For example, cats and dogs. Your data, you are given a set of data. Some are cats, some are dogs, and you're supposed to write an algorithm that will tell which one is a cat and which one is a dog. If I feed in an image, you should be able to tell me, oh, the image you've given me is an image of a cat, or the image you've given me is an image of a dog. That's supervised learning. Now you have unsupervised learning, whereby it is just scattered. There is no header, there's no head, there's no tail. Everything is just there. There are no labels to tell you what is what. Then you have your semi-supervised. Is in between both. Some of your data is labeled, and then some of your data is not labeled. So I'm going to go deep. We're not going to now go into these three, and we're going to learn different algorithms that we're going to use for supervised learning and unsupervised learning, actually those two, and then semi-supervised. So this is sorry about. Okay, so we're talking about supervised learning now. So now there are two techniques under supervised learning: classification and regression. Classification is basically like I gave an example, a dog and a cat. You can classify which ones are dogs, you classify which ones are cats within the data you've been given. And then you have some algorithms that you can use to carry out this classification. There are different types of classifications. You have your binary classification, you have your multi-label classification, you have your multi-class classification. And these are different techniques that you can use when you're carrying out this classification technique. So you have your support vector machines, you have your naive bias, you have your nearest neighbor techniques. Now, under the regression, you have things like linear regression, logistic regression, you have your decision trees and neural networks. For the clustering, regression regression is like, how do I explain it now? You're trying to find a continuous value for something in a continuous. It's like you're drawing a line. You're trying to say, okay, between this point and this point, what is the linear regression or the logistic regression between them. Then you have things like clustering for your unsupervised learning. Unsupervised learning, the data is scattered. There is no head, there's no tail. So the technique that we apply to this is called clustering, whereby everything that looks similar, we put them together in things called clusters. So under that, you have things like your k-means, your hierarchical, your Gaussian mixture, some neural networks, and the hidden Markov model under unsupervised learning. Now, we've done the beginner level, we've done the intermediate level. Now let's look at the advanced guide. So if you notice, I did not talk about things like image processing under the intermediate level or the beginner level, because image processing requires more advanced skills. So you should be able to, first of all, understand what Python is all about. You should be able to know the basics of Python, or R as the case may be. Before then, we can understand what the algorithms are all about. Because when you understand these algorithms and how to calculate some of this and the things that we need from there, then you can be able to move forward into the packages and the libraries themselves. Because if you jump that step and you go straight into this, it can be a bit confusing when you're working with things like TensorFlow, PyTorch, or scikit-learn or something. So let's start with deep learning. You have deep learning basically talks about image processing or computer vision, as the case may be. You have the fast forward neural network. Fast forward means you're taking an input and you're getting an out, and you're getting an output. It doesn't go back. It doesn't go back. It's just it just goes one direction. Well, so you pass your image through your algorithm, and you can just say, oh, this, whether it is correct or not, it gives you an output. But the problem, whether you know whether it is correct or not, is being solved by the convolutional neural network. That's the CNNs. I'm sure maybe you might have heard of a CNN or something. And then under CNNs, you hear things like ResNet or VGG models and stuff like that. Those are different algorithms under the CNN. Then you have your recurrent neural networks. You have under recurrent neural networks, you have things like your ANNs, artificial neural networks, under the recurrent guys also. Now, machine learning techniques, you now come to the scikit-learn, the Keras, the PyTorch, OpenCV, TensorFlow. Those are things you can use in carrying out your image processing. You have images and you're supposed to tell, for example, whether this image has a mask on the face or not. You can use some of these modern packages to carry out that analysis. Or you have an image and you want to tell, oh, is this person crying? With this image, you need to be able to classify it into surprised, angry, happy face, a sad face, or something, surprised face. Then you'll be able to use these different algorithms to be able to carry out those analysis within those images. Then you have very popular artificial intelligence. Now, bearing in mind that that AI, deep learning, they are kind of like intertwined. They are all subsets of each other. Machine learning is not exactly AI. AI, they will tell you AI and machine learning are partly the same. No, they are not exactly the same. They're just subsets of each other. Because if you know one, you will most likely know the other. You'll be able to work better with the other one. So when you know the machine learning techniques and you understand it better, when you get into things like artificial intelligence, where you're now going to the world of robotics, then you'll be able to work better at that level. Then you need things like natural language processing. This is basically your text. So people who do web analytics, and then you have things from the web, you pull data from different sources, and then you use your NLPs to analyze that data. You get an NLP algorithm to be able to analyze that data and say, oh, this is what this data is talking about. NLP is also, it might be used to create something called the recommender system, whereby You'll be able to say, okay, this particular movie, is it good or not? That's an example of a recommender system. Then you have big data that you need to learn, also the big data skills that you also need to learn. And then you have something like called a generative adversarial network, GAN. GANs are basically when you have two neural networks and you pitch them against each other to get another one. So you have basically that's the GAN. You take one neural network, you take another neural network. That's where the word the adversarial comes from. It is more like they're competing against each other in order to get something that is more robust out of the two. So you're creating a new data set altogether by pitching two different neural networks together. So we've basically talked about all the skills that we need now. We've talked about the beginner skills, we've talked about the intermediate skills, we've talked about the advanced skills now. So the things that can impede our growth. When we were talking about the skills, about the non-technical skills, we talked about you should be able to do some problem solving, you should be able to do some critical analysis of the data. Some of the things that impede your growth as a data scientist is that you do not have understanding of the data that you have. Because basically that's like the basics, the foundation of who you are as a data analyst, to be able to understand the data that you're being given. Because if you do not understand the data, you cannot get the insights in which the management or whoever is asking for it that they want to know. So first of all, things that can impede your growth is the lack of understanding of the data that you have. Another thing is procrastination. This one basically affects almost every area of our lives. You have your data and you're saying, oh, I will do it, I will clean the data, I'll prepare my data, I will do it, I'll do that. And then you keep procrastinating and you do not, for example, do your data cleaning process. You do not prepare your data and then you feed in that data into your machine learning algorithm. What you feed in and what is, at the end of the day, you're going to get garbage out because it is garbage in, garbage out. If you do not clean your data, for example, properly, your machine algorithm is just as good as useless. So procrastination is another thing that can impede our growth. Then refusing to learn new technologies. So I already know Python, but you forget that Python has different versions. Right now we're on 3.8 or even 3.9. You have people who are on 2.7 and they refuse to leave 2.7. And they will tell you that I already know Python. You do not know Python. Python has advanced. There are more libraries. Some of those things that you were using before, they've been taken out of the system. They are outdated and they're no longer even being used. Some of the syntax that existed in version 2 cannot be used in version 3. So if you stay in one place and say, oh, I already know one thing, I do not need to learn another, you will be killing yourself. So you need to learn new technologies. The next thing is that you need to participate in online, that means you don't participate in online projects or in the data science community. You have a community like Kaggle, or even are you on somewhere like GitHub? Kaggle organizes competitions regularly for data scientists where you can show your skill as a data science. You'll be able to know how your level of proficiency, basically. You'll be able to know exactly what you know. So I would encourage that you should go to somewhere like Kaggle and see the kind of competitions that they have and participate. Join some data science community. We already have one here in Bincom. And we'll be able to share the knowledge. So staying on your own as an island will not help you in the field of data science. You need to interact with people, you need to network. Now, the next one is the non-mastery of technical skills. You need to hone your skills. You need to use your skills and know exactly what you want to do with it. You are a data scientist. What part of data science are you specialized in? Data science is very big. It's very wide. As a data scientist, what can you do? There are different packages and libraries. There are different sections of data science. You need to master something in this field. Then lack of ownership of data. As a data scientist, you should be able to see your data from the beginning to the very end. You should be able to take ownership of the whole process. You cannot start and then drop it and say, oh, it's not my business. I've done the part that I'm supposed to do. There's nothing for me to do. No. You need to take ownership from the beginning to the end. And then the last thing is the overconfidence in your abilities. Trust me, you will learn every day. These technologies grow every day. New things are coming out every day. So you may know something today and tomorrow is no longer in use. And if you are not willing to learn or willing to relearn, you may end up shooting yourself in the foot. So that things that we need to that you need to do. This is just a few things that can impede our growth as data scientists. Now, tips to getting jobs and roles. The first thing is, like I listed before, participation in one of it is participation in the competitions and everything. It's networking. You need to join, you need to be able to speak to people, look at one person knows one person that knows another person. Those are the ways you get to jobs and roles. Go on LinkedIn. If you don't have a LinkedIn profile, you need to create a viable LinkedIn profile. Have a picture there. Put some of the things that you can do there and let your skills be there show. So as in LinkedIn is one platform that can expose you to the world. You have a LinkedIn profile. I expect that if you're already on the intermediate level, you should have a good LinkedIn profile by now. Then you need to build portfolios and personal projects. So when you're starting off as a data scientist, you need to you will see they may ask you also what level of experience. You may not have worked in the big companies, but when they see that you can make use of different algorithms to solve different things, you know how to carry out predictive analysis on your data, you know how to generate insights on your data, you know how to work with statistics, you know how to carry out use some of these packages that they need. It enhances your chances of getting a job. Unlike somebody who is just fresh out of school, or not necessarily just fresh out of school, who is just there. I know how to use TensorFlow. I know how to use PyChart, or I know how to use scikit-learn. Okay, show me. And then there's nothing to show. You have nothing whatsoever that you have used these languages to do. The next thing is to get your CV and or a cover letter. Some companies will request for a cover letter, some wouldn't, but at least most people will ask you for your CV. You need to ensure that your CV is professional and well written. Then continuous learning, you need to keep learning every day. You need to ensure that you're learning very often and you don't stop learning. And then there's a saying that they will say, jack of all trades, master of none. Narrow your job field of interest to something more specific. So you're not just looking for jobs here and there. By the time you narrow narrow down your job field of interest, you'll be able to get what exactly, you'll be able to know this is what I want and you'll be able to go for it. And then you need to build your area of expertise so that when they see your portfolio or your personal projects, you can say, oh, this is what this guy is good at. This is what this lady is good at. and they'll be able to see, okay, you fit into what we're looking for. Whether it is artificial intelligence, whether it is NLP, there are some jobs that are specifically looking for people that do NLP, an NLP engineer. There are people who there are specific jobs also they're looking for a machine learning specialist. So as a machine learning specialist, you know all the machine learning techniques. You can apply whether it's classification, whether it's regression, or whether it's clustering, all the algorithms under it. You can at least do some of them, if not all of them, as a machine learning specialist. So depending on that, you're able to build your own area, and that is your area, you own it, and you're the master of it. I think, I'm not too sure if there's any other. Okay, so different references. I put together some websites where you can go and get started. Who is a data scientist, some of the Python basics, R basics, and some of the machine learning techniques that you may need to learn. The differences between a data engineer and all that. So some references are already here for you that you can always go back to. Okay, I think that's done. So thank you very much. Over to you, Tom.
Yeah, thank you. Thank you for the lovely lecture. And I'm sure that I've learned a lot from what you have said. Thank you for this lecture. And I'm sure a lot of us also have learned a lot. So if you have any questions for the speaker, this is the time now to ask your questions. So is there anybody around us that have a question or questions to ask?
Can I stop sharing my screen? Or
Yeah, you can stop sharing your screen.
okay.
Yeah, Sunday.
Yes, please, I have a question.
Yeah, you
Okay.
can ask.
Okay, please, I want to know the difference between database and data, what's it called, data analyst.
Sorry, the difference between
the database engineer and the data analyst engineer.
A database engineer and a data analyst. Is that your question?
Yes, that's my question.
Okay, so a database engineer, as the name says, works basically with databases. I would, or more like, are you saying, will I say database engineers or database administrators? Which one?
Okay, yeah, I think that's cool.
Database administrators, right?
Administrators, yes.
Okay, so a database administrator basically would take, they are closer to infrastructure guys. A database administrator who can deploy your database. A database administrator will know the kind of, maybe for example, your Linux system. Would say, oh, for Oracle to be able to sit on this machine, it needs this kind of requirements, maybe the core, the memory, the type of memory it needs, the type of hard drive it will need. Your database engineer will be able to tell you all that, or your database administrator. But on the other hand, the data analyst is not concerned with how the database came into play. Your data analyst is just concerned that, oh, I have a database, there is data inside it, and I want to work with the data that is there. Your database engineer already is concerned about installing that database and ensuring that that database is up and running for you, who is the data analyst, to be able to work with it. Your database engineer would help you to ensure that the data is not corrupted and all your tables are well maintained and stuff. You as the data analyst, yours is just to take the data in that database and work with it. So basically that's the difference between the two. You cannot, they're not easily combined. You'll be taking too much of on yourself if you want to combine both roles, because they are both unique roles and you can master one role effectively. But combining the two, you will just end up killing yourself unnecessarily. Trust me. They are different roles and they are very, very unique in a sense. I'm not sure if I've answered your question.
You've answered it perfectly. Thank you so much.
So anybody else with a question?
Okay,
Do you
I
have
have
any
a
more?
question.
All right, you can ask.
Yes, thank you so much, man. Um, I have two questions here. The first one is I want to know if we can consider the R programming language as an independent language, or it must be used together with Python as far as data science is concerned. So the second one is about the different algorithms that you spoke about, where we have the CNN, the deep learning and all that. I want to know if we have a particular problem we want to solve, like we can have a problem such that there are a lot of algorithms that can solve that particular problem. Like, how can we determine the exact algorithm to apply to solve a problem? Thank you.
Okay. So the first question, I'll start with that. R can stand on its own. Yes. You have people who are R specialists, but most Python is more popular than R. You don't necessarily have to combine the two. If you're to ask me if you're going to choose between learning Python and learning R, I would go with learning Python first, because Python is the most popular. Python, for most most recruiters are looking for people with Python skills. So you have more job roles asking for people with Python than for people with R. Although you have some who are also specific to R, but the ratio is maybe 7-3, more of Python than more of R. Python can stand on its own, actually. You don't need to combine it. Now to the next question, as to knowing what algorithm to use. The first thing is to know the kind of what's the problem at hand. What kind of result do you want to get? In some cases, for example, is it a clustering problem? Is it a regression problem? Is it a classification problem? When you know what kind of problem you're trying to solve, if it's a regression problem, for example, there is actually not one algorithm that fits all. So you see cases whereby you will carry out decision trees, use logistic regression, use k neighbors on the same problem to calculate things, your precision, to calculate your accuracy. You now take the best out of the three. So there isn't really one algorithm that is the best that fits or any problem. Most data scientists would use more than one algorithm to solve a problem. There isn't just one algorithm. So there isn't like saying, I'll just use, for example, support vector machines if it's a classification issue now, and that's all. No, you need to use more than one algorithm. You then compare the results from maybe you're using 2 or 3, and then you'll be able to know which one to use. In the case of if it's a deep learning, the same applies to deep learning and computer vision, where you have images to work with. You need to reuse different neural networks. So whether if you're picking CNNs, for example, a convolutional neural network, there are different types of CNNs that you can. You have there's something called ResNet, there's DenseNet, there's EfficientNet, there are different VGG, there are different CNNs that are the convolutional networks out there. You use more than one also to solve what image issue that you have. For example, you have a database of images and they've asked you to show which ones are masks and which faces have masks and which faces don't have masks. You will use different convolutional neural network algorithms to be able to tell which ones. So depending on the accuracy of those algorithms, maybe you used, for example, a ResNet. The accuracy of a ResNet was 85% to tell the difference of whether the image has a mask or the image doesn't have a mask. Then you use another CNN, maybe for now you used a VGG, and the VGG has an accuracy of 95%. 95% being that you can tell whether this face has a mask on it, so it's more accurate, right?
Yes.
So in that case, you will go for your VGG instead of using your ResNet. So things like that, but there you can't just use one.
All right, now. So are you clear now, Michael?
Yes, I am.
All right, thank you. So I also have questions that I would like to ask. So for some of the people now in this community, which have some experiences in this field, they are wondering about career progression, how to progress their career. So what would you regard as the top of this career? Can they become chief data scientist? And what are some key stages before they reach that highest point for them to reach that highest point?
So you have roles like senior data scientist, you have your lead data scientist, or your team leader, the team lead for your data science. You can have things like your chief data scientist. Yes. So, but before you can get to such levels, you need to have mastered some of these techniques that we have mentioned today. And then when you from there, you'll be able to move from the junior scientist to a scientist, and then before you can then move to the senior roles. And then getting to the senior role now, you will most likely not be carrying out technical work. Most of what you'll be doing at the senior role will be your non-technical skills would be more used than the technical when you get this thing. So for you to get to that level, you need your non-technical skills needs to be on point.
All right, thank you. So what about certification now? Are certification important, or can our portfolio and past experiences substitute for certification?
Certifications, they work in both ways.
Okay.
Actually, certifications work in two ways. If for some recruiters, when they see certain certifications, they'll say, "Oh no, they'll quickly know that this person is new." Let me put it that way. And you don't want to appear like a JJC. You want to be able to appear like someone that knows what he or she is doing. So in that case, your portfolios would stand out better.
Okay.
I would say have both certifications and portfolios. So you have your portfolios, but then your certifications are like an advantage over people who don't have any. I would say have both. If you can't do both, please do both.
All right. Let's talk about salary now. So like, what is the typical entry level salary in this field? Like, also, what about someone with 4 years experiences? And what is the highest salary range you see in your field?
For the entry levels in the UK, for example, an entry level role, you'll be getting like some 30,000 to 40,000 pounds a year.
Yeah. Okay, thank you for that. Thank you.
And then for the higher roles, it goes high as 60, 70. There are some roles that you can achieve up to 100,000 a year.
Okay, ma. So what about ma? So let's talk about a little bit about it. Can you share a little bit about your own journey with us and how you started as being a data scientist?
About my own
journey. All right, okay. Ask your question before I continue.
Okay. Maybe before she goes on.
Yeah.
So yeah, I have like 2 questions. So maybe
yes, sir.
Yeah, so for the first question, I'm just asking this question from an intermediate point of view. So when you possess skills like machine learning, data visualization, and you can perform EDAs and the likes, and okay, you would want to most definitely sorry about that, you want to most definitely embark on projects, right? So as an intermediate, you'll be thinking about things like feature engineering,
Feature engineering, yeah.
yeah, stream leads, and all of those. So my question basically is here, is, with all of this thing going on in the intermediate head, what's the nature of the good data science project? What's the nature? What are the ingredients that makes a good data science project? Do they have to be in production all the time before you can present them on a resume or something like that?
No, okay, so you have GitHub. Are you on GitHub?
Yeah, yeah.
So you have your GitHub, and you've done your machine learning. You have some of these portfolios that you have created already. What are the things, like you've talked about feature engineering? You have your data. What type of features were you able to pull out of that data? What kind of things were you able to get? So you are talking about, about precision F1 score, how to calculate your mean score and all that. All those things have to be in your data, in your algorithm rather. You should be able to calculate all that on it. So when they see whoever is going through your GitHub profile, will be able to say, okay, oh, this person took this data. You were able to perform some data preparation on that data. Meanwhile, even if it's just one or two, you were able to analyze that data. You were able to clean the data, and you stated it there. You were able to now use that data, and you were able to split it into your testing and your training. And then you are able to now use after you training your models, you are now able to use the ones for testing to then validate it and then give you some evaluations using your precision. If anybody going through your GitHub profile can see that pattern, then you're good to go. It makes it more, and then you now have, after you did your data cleaning, you then put maybe a scatter plot or some correlation on, as in some plots before you now go into the splitting of the data into the training set and the testing set. So that's, if you have those kind of projects, like 2-4 of it, you're good. At least you start from somewhere.
Oh, thank you. So my second question is, I like the fact of how you highlighted the importance of soft skills, which sometimes most of us do subconsciously neglect aspects. We are more focused on technicals, and I don't know, from a personal experience, I don't know if any other data scientists experience the same thing. Or you see data, for example, you're just in a hurry to jump on it and start writing code without necessarily understanding what the data is all about, and making good intuitions about them. So my question is, okay, sometimes when you have, let's say, writer blocks or data blocks in this, how do you improve those skills? How do you improve how well you think critically, how well you make good intuitions? Because I feel they are a lot important in how
they are important. So how you can improve your critical thinking, how you can improve your problem solving skills is, for me, I'll use myself as an example. It's basically taking it one step at a time. Ask yourself questions. It's all about asking questions. So you have a data set. Let's say the data set is about, I will use my fraudulent transactions again. That's the data set that you have. And your data set, so the questions you're asking, so what type of data do I have? Now, question number one is, what type of data? Oh, it is fraudulent and non-fraudulent. Question number 2, I would probably ask myself is how many? So I'll be able to divide that. Question number 3 that I'll probably ask myself is what type of the cost of these frauds, or what time of day? If there's time, if the data set had comes with dates and time, so you'll be able to know that, oh, this fraud is being carried out in the morning or mostly at night or something. And you'll be able to now. Another question I also ask myself is the frequency. Which type of frauds appear more often? So whether it is online shopping frauds, or people or scams or something, I'll be able to. So that's another question I also ask myself: the frequency of occurrence of the different descriptions of the frauds, of the type of frauds that you have. So it's all about asking questions. The more questions you ask yourself, the more you'll be able to understand that. So when I talk about understand your data, it is mostly about see yourself inside that data and try to ask yourself more questions. That way you will improve your critical thinking. That way you'll be able to improve your problem solving skills. You'll be able to know that, oh, this is the problem. You'll be able to know the problem at hand by the time you know what kind of data you're dealing with, and you'll be able to prefer better solutions by the time you know the actions that you're going to carry out. But first of all, you need to know the type of data. If you don't know the type of data, you will not know the type of actions to carry out, and you will not get the results that is being needed. So basically, asking yourself questions is, for me, that's the basic. Ask yourself questions, ask and then drill into the data.
Yeah, I totally agree with that. And that answers my question correctly. So I think the last one would be, somebody had asked that question, though, but I just wanted to reiterate. Yeah, it's just this topic of Python versus R. We all know that these two languages actually have different approaches to data in the sense. Yeah. For some people, they want to classify them. Okay, one does statistical analysis more, and the other one does more of explanatory. Yeah, and all of this. So my question is, okay, just like you said earlier, that you don't really, that if you were to choose, right, you were to have a choice now, okay, you'd go with Python because it's more popular and probably does more advanced things. So my question basically is that, okay, those things that R does better than Python, do we have equivalent of those technologies or those tools in Python that you can easily substitute with?
In R?
In
yes.
Python, yeah.
In Python or in R?
In Python, rather.
Yes, you have. There are things that there are tools within Python that does some of these things that are in R. R is a very good language. Please don't get me wrong. R is very, very important, especially in the area of statistics, like I said earlier. R can also, there are some things that you do in R that can be shorter than doing it in Python. For example, reading your data into a data frame or something. In R, sometimes it's faster. There are some data that works better. There are some data sets that you can do better in R than in Python. So it's not, like I said, the only reason why I would choose Python over R, if I had to learn only one, is that I would take Python, is because, like I said, it's more popular and it's more advanced in some certain areas. But if I had the opportunity of learning both, I would learn R. I do both. I do both R and Python.
Okay. Wow, interesting. So, okay, yeah, I think that answers the question correctly. Thank you very much for giving me that detailed response. Really appreciate it.
That's fine.
So
Mr.
I have to
Abdul?
all right. So I have to rush through my question because we're already running out of time. So okay, now what does our next part in this field? That's data science field. What does it look like? Let's say after 2 years or even 5 years. Are there any specific experiences you need to see in their portfolios, or is it just skills? And what kind of job role can they target?
Sorry, I didn't get the question.
I say
Somebody after.
an expert in this field
Okay.
after 2 years or even 5 years.
Okay.
Are there any specific experiences that you need to see in their portfolio, or is it just skills? And what kind of job role can they target?
Okay, so specific experiences, I would need to know you in terms of experience. You should be able to tell me that what you've been able to use those skills that you have. For example, you were able to use logistic regression to carry out some predictive analysis, and you got this kind of a result. So you should be able to tell me. I don't just want to see I can use logistic regression. Yes, I know that you can use logistics regression, but when you used it, what did you get? What was the result? What did you achieve? What was your level of accuracy? How were you able to predict the data better? And when you predicted it, when you got the result, how did it help the company that you were working with, for example? So you should be able to tell me, when I used these skills, you were able to do this, and I was able to get this, maybe with some figures or something. Maybe you were able to reduce error rates, you were able to increase efficiency, you were able to reduce wastage, something that you use this data to achieve.
Yeah, ma. Thank you, ma. So this one again, how long does it take one to reach the top of his career in data scientist? And are there shortcuts? To recommend to us who are looking?
There are really no shortcuts and then it depends on, naturally, it's relative, it's individual based. It's individual based, depends on your dedication, your level of dedication, and the level of consistency that you have. But on the average, in a year or two, at least, you should be able to, if you're consistent, in about 2 years, you're good. You may not necessarily be an expert, but at least you'll be able to stand your ground, you'll be able to make contributions in that area, in that field, after at least 2 years of consistent learning and working on improvements on yourself.
So this is the last question. Are there relocation opportunities with this career path?
Yes, there are. So you have, there are some jobs that they come with sponsorship opportunities, where they are looking for data scientists in some of the countries outside Nigeria. You have in America, in Europe, in the UK, in Canada. There are jobs that come with relocation opportunities and are looking for data scientists. But you need to own your skills. You need to be able to prove that I can do these things that I've written on my CV. Because they're going to test you. They're going to test you. It's not just about writing them on your CV. You should be able to do it. And one way you're able to prove that you can do it is by showing them your portfolio. Is by showing them your portfolio, your personal projects, that, okay, these are the things I've done. And these are the skills that you're looking for. Look at my portfolio, they are already there. And then they'll be able to prove that.
I'm done this call. Yes, sir. Yeah, thank you, ma. And yes, I'm sure that a lot of us have came from out today, and we thank you for for attending this program today. So we want to tell you guys a little bit about things we do at Bincom Dev Center. This is one of the programs we do at Bincom Dev Center.
Okay.
So you can, Mohammed, okay. Let me to share your screen. Let me to put up the presentation.
Okay.
Okay, so share your screen.
Yeah, can you all see my screen now?
Yeah, I can
Yes.
see your screen. Okay. All right. So make it slideshow form so it will be big enough for people to see.
Share. Okay.
So yeah, welcome to Bincom Dev Center. And yeah, next slide. Go to the next slide. Yeah. So our Bincom Dev Center is a multi-locational technological talent development and solution platform. And we have our locations virtually near you. And one at Yaba, Lagos State, Ibadan, Oyo State, Kano, Kano State, Kaduna, Kaduna State, Ijebu Ode, Ogun State, Warri, Delta State, and we are planning to extend to other locations across the country. And you can see some of the um, since we do have Bincom listed down here, we have Bincom Academy, Bincom Tech Internship, Bincom Tech Apprenticeship, Bincom Community Event and Project, which is one that we are doing right now. And we have our light spaces we offer to people. Next slide, please. Yeah, so also we have our Bincom Global Tech program, which is where we help to develop techies to become better at the tech things they do. And Immigrate is where we provide opportunity to learn how to relocate through a tech visa from this country. And also we have tech mentoring platform where we give you a mentor to help you get better, where you get better having a mentor. That's a structured platform solution to help mentor add value to the mentee for purpose of building global attractive techies. Then we do Lab by Bincom, which is a 3 to 6 month pre-incubator program that brings together participants to build a digital technology product which would be used by real life users. So let's do them a little bit into some of our services. Next slide. So at Bincom, we have our Bincom Academy where we facilitate by Bincom Dev Center. Each technology application development class is a typical 4 weeks of intensive training. During this period, we shall take the participants through our training curriculum for each knowledge track in a Montessori approach. And the classes that are available are in Python class, we have the mobile app class, we have the PHP class, foundation class, graphics design class, project management class, the IT system engineer, the digital marketing, basic design class, and advanced front-end development class. So then the fee of this class is 50,000 naira only. And note their discount fee are available from time to time. And to know more about this, you can visit the website at bincom.net/academy. Next slide. So also, our light spaces helps provide workspace intended to encourage collaboration and drives innovation in the startup ecosystem. We have spaces that is created and designed for various events like seminar, conference, and get together. And they can contain 30 to 40 people and overstay at night and co-working space, dedicated spaces. And you can find more about our blog.net/campuses. Next slide. Okay, so our Bincom community event and project, which is what we are doing today, which is geared at giving back to the community and building a tech ecosystem that focus on informing and exposing the youth to the current technological trend and how to prepare for the future in technology. Bincom community event is divided into 5 groups. We have our master classes, we have our meetups, we have our idea sharing, and we have our explore on the move, and we have the challenge and brainstorm. And also, some of our other initiatives include Bincom Tech Network. We use Bincom Tech on the Slack group for collaboration purposes, interaction with facilitator and other participants of Bincom academic class will happen on the channel in Bincom Tech Network. Bincom Tech Network is a developer and a tech resource community powered by Bincom. We believe this will grow into one of Africa's largest community of tech enthusiasts and experts. Bincom Tech Club also is one of our initiatives. It's created an ecosystem that enables tech entities who has little unknown knowledge to teach, to learn, and to rub minds with tech experts, leveraging on the tech community to front end the what? The possibility of an individual slash club or club member to become a tech expert themselves. Next slide. So our meetups, we have our PHP meetup, cloud hosting meetup, Angular meetup, digital marketing meetup, data science meetup, Laravel/Lean meetup, DevOps meetup. And for our master class, we have the Bincom Startup School, Social Lender, and the EdTech series. And for the idea sharing, we have our Bincom ICT Career Talk, which is every Saturday, and our e-migrate open day, which showed Wednesdays and Fridays. Next slide. So the next slide, this part is the Bincom Global Tech Program, where you learn skills, gain exposure, and gain experience from them. And also, while doing this, you can also learn tech now and pay later when you start making money. So to know more about this, you can visit our website, www.bincom.net. Next slide, please. Next slide. Don't play the video. Next slide. So immigrants, pronounced emigrants, provide tech-enabled visa opportunity for people in tech, either the technical side or business side of tech. It gives opportunity to live, work in the US, Canada, France, UK. What can immigrant service owner cover? General inquiry, coaching and handholding sections, primarily assessment of your qualification status for self-directed roadmap to qualifying for a tech-enabled visa. Roadmap to a globally attractive program. Example, we help you review your UK global talent application and endorsement review processes. And you can know more about this on www.bincom.net/emigrate open day. Next slide, please. So the immigrant services, the free ones, and we have the premium ones. So and if you are interested, these are the steps to follow. We have you can indicate interest at bincom.net/emigrate with an 8 at the end. Go back and you request an immigrant service at blog.bincom.net/emigrate pricing. Next slide. So the immigrant open day is a special invitation to you have a special invitation to the next immigrant open day. With a typical 2 Wednesdays in a month. Video recording of the past editions are also available. So you can see that one on bincom.net/emigrate open day. Next slide. Next slide. Go back. No, the Learn Tech now. The global ambassador. Okay, so we have this place. So N while you learn tech. In this while you learn tech, you have the opportunity to earn while you are learning. And how you can do this is an ambassador campaign with MyCircle, bringing the ability for people to earn from their network and positive social influence. You earn 10% or from the Bincom Dev Center for any of its services which you refer. For example, you earn 10% of the payments made by prospective global tech program participants referred by you, which is 120,000 naira. For more information, you can visit bit.mycycle Bincom Dev Center/referral. That's for NYU. So go to the lab by Bincom. Yeah, so at Bincom Dev Center, we also do something called Labs by Bincom, and it's to help you build your startup from scratch with your own team. And to know more about this event, you can visit www.bincom.net/labs. And next slide. So for questions and feedback, you can contact us on the number on your screen, or you should visit our website at bincom.net at www.bincomdevcenter.com, or you should send us a mail at bincomdevcenter@bincom.net. Thank you for attending today's program, and we hope to see you at the next section. So thank you for attending, and this is where we close the program for today. Thank you all for coming.
Thank you, sir.
Yeah. Bye.
All right. Bye.